Okay, so in a bishop's implementation for this is relatively straightforward. So yeah, first what we do is if there is, as soon as we try to get the available moves, we need to make sure that this available moves is empty. Then we ask the board to give us the tile with this piece ID. So the specific item will get that tile where the specific square belongs on, and then we'll check if that tile is empty, if this still actually exists. If it doesn't, then that means obviously there is no available moves for that because it's no longer alive. Then a bishop is able to move in different directions, so like what we said in a diagonal. So here we have, for example, top left, which would go this way. Here we have top right, which would go this way. And here we have top left, which would go this way. And top right, bottom right, that would go this way. So this is what we mean, like in when we talk about the bishop can go, for example, this way. It would be able to go this way if it was in the middle, up, down, left, right. So this is what we mean when we say direction. So a direction class will just say, okay, what file are we in? So for example, is it A, B, C, D? This is the files, this is the rank. Okay, so what we then do is we go and we say, okay, for each of these directions, check whether there's a diagonal move. So what this does is it takes in all of the information like the board, the current tile, the direction, and the list of available moves that we have. It then goes and says, okay, create a file change and a rank change. And for each of the new files, just go and add on to it. So for example, this is A, B, C, D, E, F, G. So it keeps on trying to say, okay, if we had A1, for example, let's say this bishop or even this, it would keep on saying, okay, we had C now. Please go and check if this is available, if this is available, if this is available, and it will add all of these moves that are available. And if we find that one of these is blocked, don't continue checking in that direction. So this is where we go in. We go and say, okay, create a new file for this by adding on the file position. So that will be, let's say, if it's a plus or minus, it will add on top of this to either see do we need to go forward or to decide on the direction that we need to go in for that specific one. The same goes for the rank. Then we go and see what direction it is. If it's white, we decide, okay, the opponent will be black, and if it's white, if the opponent is black, then it would be white. So then what happens is while there is a valid move, we go and say, okay, take the file where we are now, and if the file is less than A, because another thing to bear in mind is like with characters can be represented as numbers and often are. This is part of the ASCII table. So each of them have an associated value. So if the file that we are now is less than A, then we know we've hit off the file. If it's greater than H, then we've hit off the file. So this is just ensuring the boundaries are in place, that we're only checking within the square. So for example, once we've hit H, we can't, for example, go and click outside of H because that wouldn't make sense. So if there is more valid moves, what we then go and do is we get that tile and we check whether that tile is not occupied, and that if it is occupied, it has to be occupied by the opposition. So while this is the case, while there is a valid move, we simply go and say get the new position. So for example, if we are on C8, we would simply go and move to D8. This is a valid position. We keep on checking, is this a valid position? Is this a valid position? And while there is a valid position, it keeps on trying to add a new valid position. So this is what happens for each of the directions. So then we go, we check the tile, we check whether it's occupied by an opponent color, we add that specific item, and then we break out of the loop because we can't move any further in that specific direction. And then we go and we add the available moves if it's not occupied by anyone, and then we continue to add on a file change and a rank change. So that's sort of how that would work for each one of us, and then the diagonal would go, and it would go for each direction. Like we said, it would go up this way, this way, this way, and this way. And at the end of that, we return all of the available moves that it has. So let's just briefly have a look at how this would look in the code. if we click on this and we, for example, go and click on this, or we don't have one on this, let's just open this up. So over here, the bishop is not clicked, but it's called, for example, and then this will say, okay, where's the current tile? This is a dark square, and it's a light square bishop that's inheriting this, and it's of color white. This is a white bishop, and it's located on position f1. So here we have the f1, and it should not have any type of available moves. So let's see if we go and check each of the directions. So we can just briefly check through each of these. So here, like what we saw, the value, although it's f, when we add on a value, it has an ASCII value. So here we have no valid. We check if it's a valid move. We go and we see if that tile is available. We go and add the specific move on here. Okay, so then we'll go on here and we can simply go and see, okay, cool, this is it. We'll get out of this, and then we'll check for each of the directions that they can move in. E2, oh, cool. So yeah, here we'll check for each one of them, and at the moment that'll check for the direction. This is a different type of piece, but the great thing about this is we're able to again treat the pieces even though they're different. Like here we have a different example. So let's just remove this breakpoint and then head out of here, and then we should now see this item being moved. So now this file is open for being able to, for example, attack. It's black's move now. So let's say black comes over here, it's able to go and check the specifics behind that. So if we had to now go and put a breakpoint on the bishop specifically, we'll put a breakpoint in here, we'll click on the bishop, and we'll put them right over here. So now we get the bishop that's here. Again, it's an f1, and now we should see a bunch of different items that come up. So the available list keeps. So here we have 5 possible positions we can go into, and then we should now see the number of positions being here, where we can go in terms of available moves. And then once we click this, again, we'll handle the direction change. We'll have a look at the different items that's there, and it generates that. So now we can see it's moved from here by calculating each of the possible positions we can go to, and then places it on that. But for example, if we want to move here, now it's, so for example's sake, we can't necessarily move here because it's not an available in its available squares that it can do. The same goes for a rook. A rook is slightly different in the sense that it checks its horizontal and its verticals. So if we have a look at how the available moves work in here, it's very similar. Again, we get the current tile with the piece's ID from the board, which is a list of squares. So again, the board is represented as each of these squares a tile. These are 64 tiles, but we've kept it as a flat list. So this is 1 tile, 2 tile, 3 tile, 4, etc., for each of them. So it's just one list of 64 items. So the way that this works is, again, we clear the available moves, we get the rook, we check if the current rook or the tile for the rook is there. If it's not, then that means the rook is no longer available and there's no available moves for that rook. Then we define the directions that a rook can move into. A rook can move vertically up, it can move vertically down, it can move horizontally left, and it can move horizontally right. So again, we'll just move in each of the directions and we check what straight moves they can do. So the straight moves again works very similar, where we have a file rank with the directions and the rank change, and we go and create a new item for each one for which file we're in, whether that's A to Z, A to H, or 1 to 8. And then we go and simply add on to each of these. Again, we'll have a look at which is the opponent. We'll check whether there is a valid move, And while there is a valid move, we simply go to a new position and get that specific tile and add it on top of it. So again, if we have a look at if it's a valid move, it's pretty much the same as a bishop. As long as it's within the bounds of A to H and 1 to 8, it is valid. And as long as the tile of where we are right now is not occupied, or it's occupied by the opposite color, then it's fine. So this is the usefulness of being able to, for example, implement something like that. So yeah, so that's the difference between a rook and a bishop. Now a queen in essence just uses the same functionality. It uses the diagonal moves and it uses the straight moves. So let's take an example of where we're going to implement the queen's moves. We'll just populate an item for the items and we'll write down where this is gonna be stored. So for example, we'll just need to implement this. We can store a1, which is a rook, on the board. We'll store a8, which is also a black rook. So this is a black rook, this is a white rook, and then we can store one of the bishops. So bishops would be on f1, f1 and f8, and then we would just store the queens. F1 would be a white bishop, while f8 would be a black bishop, and then we'll store the queen. So the queen will be on d8 for black, and then we'll store the queen for white, which should be on d1. Okay, so first things first, let's just clear the board with all the other pieces so that we can pay just attention to that specific one. So I've already created a method in here that we can only populate specific ones. So here we'll just put in these ones, which is a1, a8, sorry, what was it, a1, a8, f1, f1, f8, and then d1 and d8. Okay, so now let's just pay attention to, for example, the queen, the rook, and the bishop. And so let's start this up now and see what it does. Let's give it a sec. Okay, so now we have the rook, we have the knight, we have the bishop.